Hello grade 12s, welcome to this video on the extraction of aluminium from bauxite. Bauxite is just aluminium ore, but it doesn't contain aluminium, like just Al solid. This is not the same process as purifying, for example, impure copper. Here we are dealing with aluminium ore that contains aluminium oxide. So we want to take this aluminium oxide and basically put the aluminium ions through a redox reaction to get the aluminium on its own. Okay, so the aluminium oxide. Number one, we need to turn it into its molten form. Molten just means liquid, aqueous. It needs to be in a form so that the ions can move. So we treat it with a substance called cryolite. Cryolite is basically there to allow this to be, dissolved and dissociated into its ions. In order to make this economically feasible, you will read in your book that this over here, this solution, is also treated with aluminium fluoride. And the reason we treat it with aluminium fluoride is to lower the melting point of the aluminium oxide. If the melting point is lowered, we need less heat. Less heat is a good thing because it means we're going to spend less money on making things, melt. Okay, so that's what we're going to do at first. In our container, the electrolyte contains the aluminium oxide, which has dissociated. That's Al3 plus and O2 minus ions that are floating around. Where did they come from? The aluminium oxide. They're going to float around. This is a steel tank, and the steel tank will have a carbon lining. You should remember that carbon can function as an electrode. So in this case, the steel tank itself is attached to the negative terminal of the battery. This means that the steel tank with its carbon lining creates the cathode where reduction takes place. You're going to notice in your container, in your steel tank, we also have these rod-like structures. These are also electrodes, but they together are attached to the positive terminal of the battery. So battery or power point or power source, so they are the anodes, and they are where oxidation is going to take place. Okay, so remember we have our aluminium and the oxide ions floating around. What will now happen is that the aluminium ions will be attracted to the negative tank. Remember our tank, its carbon lining is attached to the negative terminal of the battery. So these aluminium ions that are floating around in the solution will be attracted to the tank. When they are there at the tank, they are going to gain electrons. So Al3 plus is going to gain electrons and it's going to form aluminium. In this case, the aluminium is going to remain in its liquid form because we are dealing with very high temperatures. When that has taken place, oxidation, on the other hand, the O2 ions that are also in the solution, they're going to be attracted to the positive terminal of the battery. I notice now that I'm explaining in the wrong direction, but if you've watched the other videos, I'm sure everything will make sense. So the oxygen ions, since they're attracted to the positive terminal of the battery, they're going to lose their electrons. So electrons will be lost and they will flow in that direction to the positive terminal of the battery. Of course, those electrons go through the complete circuit back over there, making this carbon lining of the tank, the cathode, negatively charged, so that this can gain the electrons since they are attracted to the cathode, the negative electrode. Okay, when that happens, so back to the oxygen, when the oxygen is oxidized, it's going to form O2 gas plus 4 electrons. Okay, so that's going to be 4 electrons, yes. And this is going to be 2, just to balance everything, right? The aluminium reaction, that is a reduction reaction. The one with oxygen, that's an oxidation reaction. Bringing these together, we can get or form the net reaction, but we have a problem here. We have 3 electrons and 4 electrons. So we first need to balance that out. We need to make them equal. The lowest common multiple of 3 and 4 is 12. So at the top, we're going to multiply everything by 4. We end up with 4, 12, and 4. At the bottom, we're going to multiply everything by 3. So we end up with 6, 3, and 12. In the end, the net equation is 4 aluminium ions will react with 6 oxygen ions, okay, in order to form aluminium liquid plus oxygen gas. Okay, so our products are the aluminium liquid and the oxygen gas over there. If you want to simplify this even further, remember that the aluminium is actually bonded to the oxygen. So you're going to see in your book, they write it down like this. They say Al2O3 is going to form Al liquid plus O2 gas. And balancing this, so this is not in its ionic form, but balancing this out, we'll put a 2 there. Over here, we will have a 4, and on this end, we will have a 3. These two are one and the same equation. They mean exactly the same thing. If you go and count the oxygens, the aluminiums on the left, you're going to find it's exactly the same. I see I left a 4 out there. Okay, so that is your net equation. Either one will suffice. Either one is okay. Now, to put things a bit further, in your book, you're going to see they say, once the oxygen gas has formed, O2, remember, we had oxygen gas forming when the oxygen ions were oxidized. So in here, we have a whole lot of O2 forming. These oxygen molecules are going to form bubbles around the carbon electrodes, the carbon anodes. They will then react with the carbon. This is not a redox reaction, but the carbon is going to react with the oxygen and form carbon dioxide. So just take note of the fact that in this reaction, the oxygen can react further with the electrodes to form carbon dioxide. For this reason, these electrodes tend to disappear with time. They're not disappearing, they react completely and disappear, okay? And therefore you have to replenish them often. So creating or extracting aluminium from bauxite is a pretty costly procedure because number one, your aluminium needs to be in its molten form, your aluminium oxide. Number two, you constantly need to replenish these anodes. So that makes this pretty expensive. But that basically brings us to the end of this video. I hope that it made sense. Again, guys, if you have any questions, you just let me know and I will help you. But at this point, I just want to say, if you have watched this video and you've made it so far, I really, really want to thank you from the bottom, top, middle, left, right of my heart. These videos take a lot of time to create, so I really appreciate you making it worth my time. Thank you for valuing yourself enough, valuing academics enough to put the effort in to watch these videos, to get the marks that you would like. I pray that you get the marks that you deserve. I wish you all the best for your exams. Thank you, and thank you again.